Hi, in this video, I'm going to talk about hoisting. Now, hoisting is something that operates from mostly under the wraps in JavaScript, but its effects are very much perceptible. So, I'll start with the effects themselves, how they play out, and then we'll move on to see what hoisting actually is, what is its definition, and what are the rules that it plays by. We'll see how hoisting differs slightly in the variable declaration and in the function declarations. Finally, we'll also see where hoisting does not occur and what are its effects. So let's start. Let's check out some code snippets to see hoisting in action. So in the first example, there are just 3 lines of code. There is a variable a where I assign the value 2 and then I log the value of variable a to the console. Let's run the code first. It prints 2. We'll now examine the code line by line a little more closely to understand what's going on. In the first line, I assign 2 to the value of a. In the second line, I make the declaration of a, which means the assignment comes before the variable declaration. Yet, the compiler doesn't complain at this point, at line number 1, that the variable to which I'm assigning the value, that variable's declaration is missing. Somehow, it seems to know that although at this point the variable a is not declared, but the declaration is going to happen in the future for sure. That is something that is slightly counterintuitive. The second thing, which is a little counterintuitive again, is that in the first line we assign 2 to as the value of a. In the second line, when we declare a variable without any value, implicitly, the value undefined is assigned to the variable, which means even if we assign the value 2 to a, since this line where a, the declaration line comes after this line, the value 2 should have been overwritten by undefined, since we are not specifying anything as the value here. Yet, when we are logging the line to the console, it seems that the value 2 is retained. We don't get the value undefined. It means somehow it looks like this declaration line comes before this assignment line, which is why neither at this line there is any complaint of the lack of variable declaration, nor there is any overwriting of the value. The value stays a, even though this line should have assigned the value of a as undefined. It seems like the line 1 and line 2, the order of those 2 lines are reversed. Let's take another example and see if the order is reversed in this example as well or not. This example is even simpler. We log the value of a to the console, and only in the next line we go about declaring and assigning the value of 2 to a. Let's see what it prints. It prints undefined. It seems in this case the compiler has decided not to reverse the order of lines. The original order is preserved. That's why when we were logging the value of a to the console, since it doesn't find anything, no value of a, it logs the value as undefined. So what's really happening? Why is the order kept the same in the second case, while in the first case, the compiler chose to change the order of the first 2 lines? Well, the answer is in the question itself. It's the compiler. It's the compiler which decides to sometimes change the order, and sometimes it decides not to change the order. But of course, it's not really random. There are rules that it plays by. But first, we'll have to understand this fact that compiler doesn't simply generate code for the JavaScript engine. That, of course, is there. But apart from that, there are 2 major steps that are involved in the compilation. One is the variable declaration. And the second is the assignment of values to variables. The compiler decides when the variable or the function declarations need to take place. This when is the key to the answer that we are looking for. What really is hoisting? You can visualize hoisting exactly like you would visualize hoisting a flag, where a person pulls the rope and the flag is hoisted or it's raised to the top. Except that in this case, the entity that is hoisted is the declaration, be it the variable declaration or the function declaration. Where is it hoisted? The declaration is hoisted to the top of its own scope. What does that mean? That means here, in the first example, we had the variable declaration A. This variable declaration, during compilation, will be hoisted or raised to the top of its own scope, which is a global scope in its case. So this is how the code actually looks like post-hoisting. So now that if we see the sequence of the code, we have the declaration of the variable A first, and only then the assignment comes in. That's why at this line, there was no complaint of the variable declaration missing because it wasn't missing in the first place. Because of hoisting, the declaration came before the assignment. Also, that's why the variable of A was not undefined, but it was 2. Because there was no overwriting happening. The assignment 2 to variable A came after the variable declaration. Secondly, in the second example, again, this declaration part will be raised or hoisted to the top of its own scope, which is the global scope. There is another part to the rule that if the declaration and the assignment are together, which is what this example is, where a declaration and the assignment of 2 to A are together, it will first be broken into the declaration and the assignment. Then only the variable declaration part will be hoisted. The assignment part will stay wherever it was. So this is what the code will look like post-hoisting. So when logging the value of A to the console, the variable A is already declared. But since the assignment is not hoisted, the value of A was undefined at this point. That's why it logged its value as undefined. I'll quickly go over the function declaration hoisting that is quite similar to the variable declaration hoisting. So here there is a function call that is happening before the function declaration. But since this whole declaration will be hoisted to the top, essentially moving the declaration before the function call, that's why we can call this function easily. Okay, so we saw how hoisting works in case of variable declarations and also how hoisting works in case of function declarations. So what is not hoisted then? One is the assignments are not hoisted, like we saw here. Assignments stay wherever they are. The other entity that's not hoisted is the function expression. Note that function declarations are hoisted, like we saw in this example. But function expressions, like this, are not hoisted. Since assignments are not hoisted and function expressions are not hoisted, so it's logical that assignment to a function expression to a variable will not be hoisted as well. So, in this example, we'll see line by line and see where hoisting works and where hoisting does not work and what are its impact. Let's forget the call bar for a moment. So here we have a function foo, and then foo is assigned at a later line a value which is a function expression call bar, which simply logs something to the console. What happens in this case? Like we saw previously, in this example, whenever the declaration and assignment are done together, they are broken into 2 parts, the declaration and the assignment, and then the declaration is hoisted to the top of its existing scope. So this declaration will be broken apart from its assignment and will be raised to the top. Let me copy and write how it will look post hoisting. So firstly, It will be broken down. And then this declaration will be hoisted to the top. So, as you can see, before the function call foo, the declaration of foo has already happened. Let's run and see how it behaves. It says foo is not a function. So, what really is happening? So, if we see the actual post hoisting look, before the function call foo happened, the declaration has already happened. But at the point where foo is called, foo doesn't really know who it is, as in, it doesn't know what its definition is. That's why implicitly the function foo is assigned a value of undefined. Now, at this point, when we try to call an undefined function foo, the engine throws a type error because we cannot really execute a function which is undefined. Okay, let's move on to the bar part. Bar is a function expression. It's not a function declaration, which means everything that is related to bar stays wherever it is. So at this point, when bar is called, forget function bar's definition. The declaration of bar doesn't exist in the first place. So when we try to call bar, let's comment out foo because let's focus on bar. It will stay as it is. So when we try to call bar, it says bar is not defined. In case of foo, foo at least had the declaration. It was just that foo did not have its definition. It was undefined, and that's why it was complaining that it's a type error because we are trying to execute an undefined function, foo. But in case of bar, the declaration itself doesn't exist. That's why it says that there is a reference error that's happening here. Bar is not defined at all. So in this video, we started with observing the effects of hoisting. Then we went on to explore what hoisting actually is, why it behaves the way it does. Then we went on to see how hoisting behaves in case of variable declarations and then in case of the function declarations. Finally, we saw how hoisting does not occur in some of the cases, and it's a fate. So, if you like this video, please consider liking, sharing, and subscribing to my channel. And if you have any feedback, I'll be happy to take up in the comment section. Thank you so much for watching.